Okay, this is part 2 of notes 3. Sorry I got cut off in my last video. So g of x is equal to 3x plus 5, and we're going to be plugging in w plus 4. So anywhere I see an x, I'm plugging in w plus 4. So this is 3 times w plus 4 plus 5. I just bring down the plus 5. And then I'm going to distribute that 3 inside. So again, what that means is to multiply 3 inside. So 3 times w is 3w, 3 times 4 is 12, so it's going to be plus 12, bring down the plus 5, and then combine like terms. 12 plus 5 are both just single numbers, so those add up to 17. So then I get 3w plus 17. So that means g of w plus 4 is equal to 3w plus 17. Okay, then I'm going to plug in x minus 2. So 3 times x minus 2 plus 5. So anywhere that I see an x, I'm going to plug in x minus 2. I'm going to distribute the 3 in. And then I get 3 times x, which is 3x, and 3 times negative 2, which is negative 6. Bring down the plus 5. Combine like terms. So 3x minus 1. So then I get g of x minus 2 is equal to 3x minus 1. That is my answer. Okay. Same concept for this one, but notice that now I'm not only plugging in numbers, I have a lot more variables that I could be plugging in. So for g of a, anywhere I see an x, I'm going to put an a. So that means this is equal to 4 times a minus 3. That's my answer. There's no way I'm able to simplify that, so that's just going to be my answer. And then I'm going to plug in x plus h anywhere I see an x. So then I have 4 times x plus h minus 3. I'm going to distribute the 4 in, which means multiply. So 4x plus 4h minus 3. And that would be my answer. So g of x plus h is equal to 4x plus 4h minus 3. And I can't combine any terms here because x's are different than h's, different than single numbers. Okay. Notice this one, it says I'm plugging in x for all the x's, which means nothing's changing here. I'm just going to have 4x minus 3, just like my original function up here. So that's just my answer. And then over here, I'm plugging in 1/2, so g of 1/2 is equal to 4 times 1/2 minus 3. 4 times 1/2 is 2. 2 minus 3 is equal to negative 1. So g of 1/2 is equal to negative 1, or I would write this as the point, 1/2 negative 1. And that would be my answer. Okay. Last concept is finding, not last concept. Next concept is finding function values from a graph. Okay. So here I'm looking at graph h of x, and then I'm plugging in these x values now into the graph to try to find the corresponding y value. So h of negative 1, I'm going to find negative 1 on the x's, so that's right here. And then I'm going to either go up or down to meet my blue graph. Well, I can't go down because there's no graph down there, so I have to go up. And I go up until I hit the blue graph at y equals 2, which means my answer is 2, or in other words, negative 1, 2. Okay? And when I do that, that's when I form that point right here, negative 1, 2, which is right there on my graph. Okay, then I have h of 2, so I find when x is equal to 2, I go up to meet the blue graph at y equals 1. So that means right here at 2, 1, I have my answer. Okay, then I look at when x is equal to 5. Well, here is when x is equal to 5. I need to go down to meet that graph. But notice when I go down to meet that graph, I'm met with an open circle. Remember that these open circles means not included. Okay, which means that even though it looks like I can find a point where x is equal to 5 here, I can't include that value. So that means h of 5 does not exist. So I either write D and E, or I wrote does not exist. Okay, and again, that is because of this open circle here. Okay, then I have something a little different, and I have h of x equals 3 and h of x equals 0. These are now my y values that I'm trying to find the x values. So h of x equals 3, so I need to find the y value 3. Here's my y value 3, and this time instead of going up or down to meet the graph, I need to find an x value, which means I need to go left or right. Well, if I go right, I'm not hitting any graph, but if I go left, I hit the graph right here, and that would be -4 as the corresponding x value. Okay, so that's this point right here. So that means I could write my answer one of two ways. I could say my answer is x equals -4, or I could write it as a point, -4, 3. Just make sure you're writing your x and y's in the correct order. And then lastly, h of x is equal to 0 means I need to find when y is 0. Well, when y is 0, that is this value here. Okay, because remember, this is the y-axis, and this is when y is 0. So it's that entire line that I highlighted in yellow. Notice when I drew that line, it crosses through my graph 2 times. It crosses right here at 4, and it crosses right here at -3. Okay, which I have 2 possible values. I have x is equal to -3 and x is equal to 4, or I would write that as -3, 0 and 4, 0. Okay, now I have the graph y is equal to f of x, and it wants me to find f of 0. So remember, inside the parentheses is my x value. Okay, so I need to find when x is 0. Well, here is when x is 0, and then I have to see where I need to go up or down to meet my graph. Well, I have to go up, and I meet it right here, that blue graph, when y is equal to 3. So that means this is my point. So I would write equals 3 or 0, 3. Then I need to find f of -2. So this is going to be my x value, -2. -2 is right here. I can go up to meet my graph, and that would be at the corresponding y value 1. So f of -2 equals 1, or I write the point -2, 1. Next one is f of 5. Okay, f of 5 is right here, but notice, just like the last graph, I have an open circle here. This open circle, that open circle here means that it is not included. Versus this closed circle over here means included. So I could pick a point. I could have a value over on this side, but I cannot have a value over on this side, which means that f of 5 does not exist. So I write D and E. Does not exist. Then I need to find f of x equals 0, so that's my y value. and f of x is equal to negative 4, my y value. So when y is 0, that is everywhere it crosses through the x-axis, because that is when y is equal to 0. Well, it's equal to 0 at 2 spots. At negative 4, and it's not quite on 4, so I'm just going to say 3.75. So that means I have x is equal to negative 4 and x is equal to 3.75, or I would write the points negative 4, 0, 3.75, comma 0. And then lastly, when y is equal to negative 4, here's negative 4 on the y's. I would have to go to the left to meet my function. I meet it right here at this closed dot. Closed dot means it is included, so I can match it up with the corresponding x value, which is negative 5. So this is x is equal to negative 5, or I can write negative 5, negative 4 as my point. Okay, last concept, domain of a function. It says to find the domain of a function defined by y is equal to f of x, keep these guidelines in mind. Exclude values of x that make the denominator of a fraction 0, and exclude values of x that make the expression within a square root negative. So all this is saying is that we exclude x when the denominator is 0, and we exclude x if we get a square root that is negative. Okay? So when looking at each of these, it's going to be case-by-case basis. So since this is a fraction, I know that I'm going to look at the denominator, and I know that the denominator cannot equal 0. Okay? So can't equal 0. So I'm going to do 2x minus 1 equals 0, and I'm going to find the value where it turns the denominator 0. So I'm going to first add 1 to both sides. So I have 2x is equal to 1. Then divide by 2, and I get x is equal to 1/2. That means if I were to plug in 1/2, so this is me doing my little check my work off to the side, 2 times 1/2 minus 1 gives me 1 minus 1, which is 0, which I don't want 0. Okay, so when I write my domain, I want to exclude that number 0, or sorry, I want to exclude that number 1/2 so I don't get 0 in my denominator. So that means my domain is going to be all real numbers, so negative infinity to 1/2 union 1/2 to infinity. So it's all real numbers excluding one value, and that is 1/2. When you see this in your answer, in your domain, that 1/2 union 1/2 tells us this is the only number we are leaving out of the domain, which means our domain is all real numbers. So any number you can think of except 1/2. Okay, so then we do the same thing. We have a fraction, so I look at the denominator. I know the denominator can't equal 0, so I'm going to do x squared plus 9 equals 0. Subtract 9, and I get x squared is equal to negative 9. Well, before I continue, I have to think to myself, if I square a number, will I ever get a negative number? And the answer is no, which means no matter what number I plug into the denominator, I'll never get 0. So my domain is negative infinity to infinity, or you can write all real numbers. Okay, this one is no longer a fraction, but it's a square root, and we know that inside the square root cannot equal a negative number. which means that we need to see what value this will give us if we make it negative. And in order to make it a negative number, it has to be less than 0. So I have x plus 4 is less than or equal to 0. Okay, less than makes negative, which we don't want, so we're trying to find out what values make it less than 0. And the equal to make it 0, which it doesn't really matter if it is 0 or not because we can take the square root of 0, but we're going to just for now say less than or equal to 0. So I'm going to subtract 4, and so I have x is less than or equal to negative 4, which means if I plug in any number smaller than negative 4, for example, negative 5, then I'm going to get a negative number, and I don't want that, okay? Which means I don't want any numbers smaller than negative 4, but I could have all numbers greater than negative 4. So my domain is going to be bracket negative 4 to infinity, because I want the opposite of this. This is what I don't want. So I'm going to say don't want, so I choose the opposite. This is the opposite. All of these values right here makes it negative, which I don't want. This is the opposite, so all of these positive values will make sure that this is not negative, so that would be my domain. Okay, this one is not a fraction and it does not have a square root, which means there's not really any restrictions that are going to be on this. We don't care if it's negative and we don't care if it's 0. So for this one, the domain could easily just be all real numbers. Okay, now we have another fraction. So again, we're going to look at the bottom. Remember, we don't want this to equal 0, so we're going to see what value will make that 0 by setting it equal to 0. I'm going to add 9 to both sides, and I get x is equal to 9. Okay, which means my domain is going to be all real numbers except the value 9. So negative infinity to 9, union 9 to infinity. Okay, another fraction, so I'm going to set this one equal to 0. So I have 4x squared plus 1 equals 0. Subtract 1. 4x squared equals negative 1. Divide by 4. X squared is equal to negative 1/4. And then I think to myself, is there any possible way that if I square a number that I will get a negative number? And remember, the answer is no. So my domain here is all real numbers. Remember, you can do that or little fancy r. Okay, here I have a square root, which means I need to see which of these values would make it negative, and I need to avoid those values. So x minus 2, and I think I changed it in class, so let me change it to reiterate this, that not only now is it a square root, but it's in the denominator. So that means it can't be negative, and it can't be 0. Okay, so that means x minus 2 has to be, we're finding all the values that are making it 0 and doing the opposite. So x minus 2 is less than 0. So I'm going to add 2. So x less than 2. Okay, so that means all values smaller than 2 will make this negative. All values smaller than 2, which means we want values greater than 2. but we don't want to plug in 2 because we would end up with 0 on the denominator, and 1 over 0 is undefined. So when we write our domain, this is going to be parentheses 2 to infinity. It's no longer bracket 2 because bracket means we are including 2, and if we plug in 2, we'll get 0, and again, we do not want 0 in the denominator. So it's parentheses 2 to infinity. And then this one has no fractions, and it has no square roots, so we don't have to worry about any special properties. So the domain here is all real numbers.